All right, hello class. This is going to be our intro to classes sort of lecture that I'll post here for CompSci 200. And we're going to just jump right into it. Now we're going to learn about just the setup and makeup of classes. We're going to cover sections 13.1 to 13.3 here and get into not only the why but the how of classes. So we will first start with just a quick um, discussion about what is object-oriented programming. OOP is a completely different animal compared to what we've been programming, which has been procedural. And procedural programming, of course, just is a start to finish, top to bottom, step one through step whatever. And that code is just simply executed in order. With object-oriented programming, the shift is dramatically different here. Rather than us focusing on operations in order, what object-oriented programming does as a main difference is it becomes object-centric. So the objects that we create are going to be forward. They're going to be paramount. They're going to be what we're really designing for. And our interactions will demonstrate these relationships and dependencies between objects. Our programming, of course, will have a procedural component to it in our main function, but we'll see that our objects will go ahead and execute their methods, manipulate their data with very little instruction from us in the procedural part of the program other than just simple instructions. So we will see a marked shift between procedural and object-oriented in this class especially, and we're going to be doing this all object-oriented programming. Now, a couple of the limitations in procedural, and the book mentions this. One very bad thing is, and this is a giant X, is that with procedural, if we have a change in underlying data structure, well, then that pretty much results in a rewrite of the program. So data structure changes are hard in procedural. And yet we'll see with object-oriented programming that we will divorce the data structure from the data and the objects. So if a data structure changes in the main program, it's going to have zero impact to our objects because our objects aren't going to care about what container they're in. Our objects are just going to care about what object that they're actually creating. The other problem is just that procedural sometimes gets very hard, especially if it's a multi-thousand line program. It's very difficult to troubleshoot, to purposely try and break your code because there's just so much code and so much happening here that it'll be very difficult to just pin down that this line is the culprit. But object-oriented kind of changes that because if there's an issue, it's going to be very close to our class and probably involved with our class. So those are just some of the changes. Now, when we get into class definitions and object-oriented programming, it's going to start with the class. So this is a class in C++. And a class is just like a struct. We dealt with structs both in CompSci 100 and 110 and in CompSci 165. So at this point, we should know what a struct is. A struct is a way to encapsulate some data into a single object, a single entity, and still be able to access that. So a class in C++ is really just sort of the next generation of a struct. A struct had data elements, and a class will have data elements. A struct will have this encapsulation, and a class will have encapsulation. The main difference, though, between a struct and a class for us is going to be that the class is going to have just a lot more functionality and features. So whereas a struct might have just a couple of data elements, a class will also have data elements. And then these are frequently called data members or members of the class, okay? So that's kind of the same with a struct, but the class will also contain methods. And methods are many functions that are part of the class. If any object is created, then it will have access to all of those methods in the class. And these methods might be ones that we use to manipulate the data elements in the class. Our methods will allow us to access the class members and then to manipulate them. So that's the biggest difference between a struct and a class, is that a class will also contain the members and the methods, okay? Now, a class in C++ really is nothing more than a blueprint. A class is not an object, and an object is not a class, but instead it's that typical model here where, like, if we have a blueprint here for a house, right? There's my house, and this is the blueprint for it. You know, it describes all of the things that you have to do to build this house, right? Now, can we say that the blueprint is a house? Nope. Can we say that the house is a blueprint? Nope. But what we can say is that the house is a template. I'm sorry, the blueprint is a template to create a house. Or in other words, if we follow this blueprint's directions, well, then we could safely build not just one house here, but we could build as many houses as we want based on this blueprint. Now, this directly correlates to our object-oriented programming in C++, because this blueprint here is what's going to be known then as the class. Oops, let me redo that. Okay. The blueprint is going to be known as the class. And whatever the blueprint is used for to create or to build, those are our objects. So similarly, if we had, let's say we had a blueprint here for a car. Well, then we could use that blueprint here and then go ahead and create this car and this car and this car and as many as we want. Now we can say that each of these cars was created by the blueprint, just like we could say that each of these objects was instantiated using the class, okay? So every class will then have instances of it, and those words are going to be used a lot in our programming, instances. And every instance of a class then is an object. So each of these cars then could be considered an object created by the class. And the class, of course, being the blueprint. So this terminology is going to be very, very important for us. You'll hear me say instances all the time, and an instantiation of the class is always an object. Now let's take a look at a class definition itself. Any particular class will be defined then by some attributes or members or variables. All of these are kind of the same things. And then, importantly, it will be defined by methods that will manipulate, access, encounter, use any of our member variables. So we'll have methods. And if we remember from what I just said, methods really are functions. And you'll hear me go back and forth between those, but primarily use methods because class methods are the prescribed terminology for this. Now, when we have our class members like this, both members and methods, what's interesting about classes that has not been prevalent with structs is that we can change the access level for each of these. Now, by default, we're going to have what is called a private interface, or a private protection level in general. And this is the default behavior for C++ classes, is that our member variables, our attributes, those are always going to be considered private. And that's considered a key part, a key bonus, a key feature of C++, is that C++ keeps its member data private. And what we do with that is, well, we have to protect our data. We don't want just any unauthorized code outside of this class trying to access this data. So we are very protective about it. Only authorized methods can come in and reach out and touch this data. So what are these authorized methods? Well, those then are going to be the methods that we define in our class. And these then will generally be defined as public methods. Public means that we can access them outside of the class. So what does that mean? Well, that means that we could do a statement as simple as this, if you remember from your CompSci 165 days when we went over this, is that if we were to use some kind of a method like a get or an output in our main program, that as long as we attach an object name to it and we've got authorization to use that method, well, then it's going to go ahead and execute. So data hiding is an important part of our C++ coding, a very important part of classes, and a very, very critical part of advanced coding. When we get to developing applications and whatnot, we want to keep that protected data, okay? So the way then that we would access that data, if this is private data right here, the way we access it then is through this public method. We will use a public method that's authorized, and there may be some data validation and whatnot, but that's how we then will reach out and either obtain or manipulate that private data. All right, so recognizing that, let's get into the actual kind of creation of a class itself. Here's creation of a class. Okay, let's get into the creation of a class again. I had to pause a little bit and put a charger on. Now, when we create a class, we are going to be sort of doing what we knew with a struct, but we're going to be amplifying it. So our general format is going to be where we first call the word, the C++ reserved keyword class, and then our class name that we define, just like a struct name. And we'll follow the same convention with structs, and that is that class names are always capitalized. This is a matter of convention, and that's so a casual reader of your code is going to be able to immediately ascertain that this is a class because it's capitalized and not just some regular data type or regular variable. Okay, so that's the key difference there. Always capitalize the name of the class. Now, in our case, what we're going to do here is we're going to create, and I'll do this kind of as a running example as we go on here. But let me create a class for a house. All right, so this will be class house. Now, our format for this is going to be simple. We will have class as the reserved keyword, house capitalized. We will have our braces. Just like a struct, you have to have that closing or terminating semicolon after the last brace. That's a little unusual because we normally don't have to do that with any other code blocks in C++, but for structs and classes you do. That's just the rule. And basically between this, we just go ahead and declare all of our member variables and our private methods or our public methods. So what would that look like for a house? Well, let's say that we know, well, some data attributes concerning a house might be, okay, the number of bedrooms, the number of bathrooms, and then how about the color of the house? So that'll be our three data elements, or three attributes that we'll try and capture here for our house. So given that, then we know if those are the three attributes that seem to reasonably describe an instance of a house, well then let's capture those as private member variables. So we would then use the reserve keyword private, and then we just declare those member variables just like a normal declaration of any variable. Okay, so we might have, int for bedrooms. Let's have a double for the number of baths. Let's go ahead and have a string for color. And that defines then the three attributes or data elements that will represent for us a house, which is an instantiation of this class. A house is, the blueprint we create from the blueprint. So those are going to be our private member variables. Now, what we have to do next is to figure out, well, what methods will we use for these? And for that, we'll use the public access specifier. Now, most of our methods will be public. There'll be a few private ones that we might get to this semester, but if you take the full-blown, let's say, data structures course, you'll get into a lot of those examples where you actually have private methods. But for the most part, our methods are going to be public, and that is the authorization level or the permission needed to access that data. You have to go through a public method to access it. So, what would typical access be? Well, a very typical one is going to be to either access or to set the private member variables. So here we've got bedrooms right here, and let's let me see here. Hang on one second. I'm going to pause it. Okay, so our primary set, or very first set of public methods that we would want to create in any class is going to be what's considered the setters and the getters, or the accessors and the mutators. So, what are those? Well, let's take a look here. I'll go back to black here. Setters, which are also called mutators, are methods that are going to actually manipulate the data. It's going to reassign it. It's going to do whatever we need to do it. It's going to manipulate the data. Whereas a getter or an accessor is only going to retrieve the data. So once we retrieve it, well, then we're good and we're done, and we should be happy. So these are kind of the two types of public methods that we'll create. And then, of course, the third type is just any other type of method that we will need. But these are kind of the two generic ones that we're going to start with. So the way that a setter would work is that we would create a function that would simply set that private member variable. And we would typically do it like this. Void, it'll be a void function because we don't have anything being returned to us. And if we were to set the bedrooms, and then provide it with an integer, well, then later we can then go and define this. Now, it's sort of like we're going to have function prototypes in our class definition here. So all of these really are kind of considered prototypes. And it's later, after the class definition is done, that we'll go ahead and type up the implementation of these various functions that we're creating. So that's what a setter might look like. We're going to set the number of bedrooms, and we're going to give it an integer. And that's, of course, going to then pass through to the function. And then we can use that to set some kind of a private member variable. So how would we do that? Well, let's talk about that right now. What would be a setter here? So if we did that same thing, there's our prototype that we would use up in our class as one of our public methods, okay? But then after that implementation or that definition is done, well, that's then when we have to start coding some implementations. So here's how the implementations will work for us, and you'll see this in the book. Well after our class definition here is done, and we're past now the terminating brace and semicolon, that's where we have to then define these various methods. Now we're going to do explicit declarations of these definitions at the onset of this class, but in 2 modules, we're going to really start to abbreviate our code with inline functions. If you're familiar with or if you remember inline functions, put those away for right now, and we'll come back to them in about 2 modules and start to incorporate those. So meanwhile, then, how would we actually then define this, this method that we're trying to create to set the number of bedrooms for this object? And the way we do that, is we would just create our function definition, just like a normal function definition. This is going to, though, follow right after the class declaration, with all of this code, and then we'll have all of these function definitions. And what we do here is then we first start with the word house and 2 colons. And that's what's called a scope resolution operator. Scope resolution operator. Let me jot that down to show the terminology, and then just how important it is to make sure that we are calling these things by the right name, and we can then all point to the right things, right? So this scope resolution operator, what that's going to do for us, it's going to tie this method to the class name, house. So since we're defining this outside of the class declaration, that's where we would do that. And then we would just simply do set bedrooms. And this is going to take an int, and let's call it, how about BR is our formal parameter name, the temporary variable name that comes in there. And then here we would just simply set the number of bedrooms to whatever gets passed to us as the formal parameter name. So let's trace this out, and you'll see that BR is the formal parameter name of what gets sent to this method. That then is going to get passed through to here. That assignment then, and this is critical, that assignment then is going to assign whatever we passed in BR, it's going to assign it to the private member variable bedrooms. So you'll notice that we never actually accessed bedrooms directly, but we did it indirectly through this set bedroom method by giving it one of the required parameters that it needs, the BR parameter. So that's what a setter is going to do for us. Code like this, and it's going to just literally set one of those, but not directly. It's going to do it indirectly through this setter method. So that's what a setter does. Let's look at next a getter. And let's go back to black here. Now, a getter is the same thing. Up here in our public declaration area, we will have getter methods, and the getter methods will return a particular value. Like, let's say we wanted to get the number of bedrooms. It could look as easy as this. Integer get bedrooms. It doesn't need any formal parameters because all we're doing is reaching out and obtaining the number of bedrooms. So this sort of serves as the prototype in our class definition. And now we need to go ahead and do the implementation. So then in our implementation code, that would look like this. Int, we still use the same scope resolution operator, and that's going to be the class name and 2 semicolons. Then we use our method name. And then these are just normal functions, and they don't need the closing semicolon for these. And then here, all we're going to do, to get the number of bedrooms, we're just going to return the number of bedrooms. And there we go. So what this does for us is if we call this little method here of get bedrooms, it's going to give us the number of bedrooms. How is it going to do that? Well, we're not going to access it directly. It's not like we're typing in count bedrooms, because we can't do that. Bedrooms is a private, protected member variable, and we can't access directly. The only way we can access it directly is through one of the authorized methods, and those are going to be our public methods. So that's how we would then do a getter, okay, a simple getter. So now let's kind of then put this all together, and that is, well, how then can we actually create an instance of a class or creating an object? So let's look at that next. All right, so given kind of some of this preliminary stuff that we did, the way to create a house is just like if we had a native data type and we're going to create a variable for that. Like if we had int balance, well, we're going to follow the same thing. Int is just the data type, and this is the variable name. So we're going to do this exact same thing to create an object, except we're not going to use a native data type. We're going to use a programmer defined data type, which is the class. A class is sort of nothing more than a programmer defined Uber data type. So here we would have house. Okay, so this is going to be our class name. And that's really secret code for a programmer defined type. And then let's call it a variable for the instance. I'll just call it my house. How about that? And that is the same thing. It's just a variable name. Although in this case, we would be more correct in saying that it's not a variable, but it's an object. An object is an instantiation of a class, just like the variable is an instantiation of a native data type. So this is an object, and now our object's name is my house. Okay, my house. Now, the way that we then access these various methods is my house, and then we use the dot operator. This is the exact same thing as the dot operator with a struct, the exact same concept. We'll use this dot operator then to access the public methods. This is important to realize because in our main program, when we create an object, we're not going to be able to directly manipulate that object's private member variables because the data is hidden, the data is protected. We have to go through these public access methods like set and get, and we'll get to some others later. So if we wanted to like set the number of bedrooms in this case, well, then we would just simply call that public method to set bedrooms. And then if we remember right, the set bedrooms method, in our case, it requires an integer, and that integer is then going to be used to set the number of bedrooms. So here, if we called this instruction, it would set the number of bedrooms to 4. Same thing if we did like my house set color, and we gave it the string blue. That will then go ahead and create that chain back. It's going to be the way we access that private member variable, and it's going to set blue then to whatever. Now, if This method right here happens to be a private method, or if we try and access a private member variable using the dot operator, like in our main, if we try to do my house dot bedrooms, maybe we're going to count that or something. This is going to draw an error. And why will we have that error? It's because we are trying to access private member variable directly rather than indirectly. So this violates the data protection principles and the data hiding principles. So you will get an error if that happens. So what I've done next, and let's go through this then next. I'm going to stop this this share, and I have got an example in my IDE here. I've got Eclipse, and I'm on a Mac, so this is what Eclipse on a Mac looks like. And here I've created a house class, and this is going to really kind of model the rectangle class example in the textbook. So here is our class definition in its entirety. So note, first of all, in line 4, the house name is capitalized. Class is not, but the class name is capitalized. We've got these 3 private member variables: bedrooms, bath, and color. And remember, since they're private, we are hiding and protecting that data, no unauthorized access. And then here, I've got our typical setters and getters for each of these private member variables. Each private member variable will have both a setter and a getter. So if there's 3, then you'll have 6. The first 3 are setters, and then the second 3 are the getters. Now let's look, all of these will follow the same kind of form. So let's just look at the set bedrooms function. And set baths and set colors is going to do the exact same thing. And you'll see me, I'll post this code to Canvas, so you'll have it as a resource for you right away as soon as you view this module. Now, like we mentioned on before, and when I was on the whiteboard there, here is what we do to set the number of bedrooms. It's going to take that formal parameter, an integer, br, and simply set that to bedrooms. Note here that this bedrooms has to match this bedrooms because we're setting the object's private member data. It's like an object will have a couple things it has to manage. One of those is bedrooms. It's gonna access that. So that's what set bedrooms does. And if we kind of scroll through this, we'll see, okay, well, set baths is going to do the same thing. It's going to accept a double. And the formal parameter name I'll use is just beat. That's very common to abbreviate these very, very shortly. And then you can then set baths to whatever got passed in by B. Same thing with color. We'll set the private member variable color to whatever gets passed in by C. All right, so those are our setters. And if we remember from our getters, our getter is just going to be an authorized method to actually obtain the data. So here, we're just going to get the number of bedrooms. How do we do that? We just return the number of bedrooms. So return bedrooms. Here for get baths, we're going to return the number of baths. Here to get color, we're just going to return the color. Okay, so that's the setup of our class implementation. Now, again, as a matter of nomenclature, the highlighted part here in my code, that's the class definition. All it contains are prototypes for these different methods that we're trying to create. Then when we create them outside of the class, we're going to create the implementation, or how we're going to actually implement these methods. So all of this code here is considered an implementation of the class. Then you'll see here, of course, we've got then our main program. And in line 53, that's where we create the house object. House, my house. It's just like int average or whatever. We're just using a programmer defined data type house. And ours is going to be called my house. Now I've got a little code block then that's actually going to set the three private member variables. And we do that using the three the three setter functions that we created: set color, set bedrooms, and set baths. And each of those requires an argument. Color requires a string, bedrooms requires an integer, and bathrooms requires a double. So there's, in a nutshell, how we do that. And then at the next code block is where we're going to use our public access methods to access these private member variables. So this is where we call myhouse.getColor. Well, let's see what happens when we do that. Let's go up to the function definition here, house get color, and we see that, yep, there is in fact, oh, it's this one. There is in fact a public method to get the color. So when we go and look at get color, here's the implementation, and it's to actually, it will actually return the color. So what happens here in this count statement is that this method call, or this function call, will be replaced by simply the color of the house. And we go on then to the next instruction, which will be to get the number of bedrooms and to get the number of baths. So you can see here that when I run this code over here in the console now, and let me get this highlighted and I'll kind of circle it here. I've got my console on the right side. You can see there where all three of those member variables are being properly accessed and then properly outputted. Now, to contrast that, let me do an intentional error here. I know that myhouse.color should be a valid method. I mean, it should be a valid instruction because we can access the elements with the dot operator. But you'll notice here that we did get an error in our console, and let's kind of trace this through. Let's see, let me turn wrap on. And we can trace it through, and it says, well, wait a second, color is a private member variable of house. So because of that, we can't access it directly through the dot operator. So that is why we can't get just the dot operator to directly access those, because of our data protection principles. Instead of directly accessing the color, nope, we're going to use an authorized method, which is going to be the get color function that we've created. And then when we run this, we'll see that all goes back to normal. And there we've got the normal output. So that does describe the behavior if we tried to access it. All right, so that's all we're going to kind of cover in our initial discussion, or our first introduction to classes. Now, if you have an additional method that you have to create, you would just simply create the method here. Let's say that we wanted to do a method for outputting the house data. Well, that's going to be quite easy. There's our function prototype. Let's go ahead and create a method implementation for it now. Again, using the access specifier, public, so it goes there. We'll use the scope resolution operator, house, and then we've got the name there. And then here we would just, however we want to output our house is how we would do that. Let's say we wanted to count maybe a little header here. And then perhaps we want to, let's tab it over and we can say bedrooms. And then we can actually do it like that. So there's our output house. And all we're doing is counting. We're deciding kind of what the format of our output should be. And then when we go to output our house here, let's go ahead and change this code. I'll actually comment this code out for now and show, well, since we created a method for outputting the house, well, we can actually use it now. So let's get this running and we'll see how the output changes. And there's kind of a different presentation of the object data, but it is showing all of the 3 data elements in the house. And it did that because we created a method for it. Here's the output house function prototype. Here's the output house function definition or the class method implementation. And then our call for it is going to be my house dot, and then we call its own public method for outputting the house. So that's an idea of how we can go about creating other methods. And as time goes on, we're going to be creating a substantial number of these additional methods. So that is it in a nutshell today. I hope this serves as sort of a good primer for you to get started in your coding. And please join me Saturday afternoon at 3. Normally it's at 1, but this Saturday has to be at 3 because of a schedule conflict. If you have any questions, again, I want to encourage you to start your coding early. Don't wait till the last minute. Don't wait till Sunday. I don't answer any calls or requests for assistance Sunday evening starting at 8. So don't procrastinate. All right. Thanks, everybody. Take it easy.